Okay, so let's start with client side. Just as a forewarning, I am not going to be able to run any demos for you because I was never able to solve that issue where basically my demos don't work for anything using the LidGrin library. So I had to use someone else's computer to test my demos. So I'm going to need you to do that for me because I can't do it. Um, but I will happily go over the code. So start off with the basic networking. Um, we can go over the data queues. So I do have my messages. You have just a basic data message, which has your message type, enum, and then a message destination and message reliability. So basically, my base class just has these three variables that um, will be set by all of the messages that inherit from it. So just going down the list, for my collision message, we have our serialize and our deserialize. And then when we execute for collision, we are just basically calling the accept. So this is obviously only for, I am on the client side, I do have it on both, but this isn't being used here. But this is obviously only for the server to run. And then every message will also have the set message settings, which is the message destination, reliability, and channel. And then the set message data. That's basically just so that you don't have to, you can just pass the parameters in one line instead of having to do every variable. So then in our input fire, that is when the player obviously like clicks a button, and that will fire, and we have the input lane mine as well. So basically, and then we have input message. So basically, anytime any input's done, this is, I needed to create this because this is what the client sends to the server to let the server know that the player pressed a button. So then basically it just shows the player and then what action was done. Was it a fire missile or a lay mine? And so this is the input fire messages what the server sends back to the player. So basically on execute, it'll just fire the missile for here, and then it'll lay mine in lay mine. So in our move, this is pretty basic. This is just called, it just tells us to move pretty much. We'll see that soon. And then we have our missile move update, which stores the missile ID, the player, the position, velocity, and angle. We serialize those, and then when we call execute, um, we set those, and we also update our prediction. So right now we're in client side. So when we update our position, we'll go over that later. But yeah, we do some various, pretty much the same thing in the player move update. So we have our message queues, our input and output queue. When we process them out, we determine whether we're going to send it over the network and or locally. And then I also have my factory. I did this I'm not lazy, just a simple way because I guess it can't be lazy because it's so much more tedious. But I like it would have taken too much time for me to deal with generics, and so I was like, you know what, I'm just gonna do this the way I know. And so I have this stupid switch case that basically just creates them, and then I have my message pool, which has obviously the pool, and then, or sorry, the data message factory itself. We were in the pool, and then we just have create message and recycle message, which will get them from the pool and put them in the pool if we need to. So obviously, we get the message type in the pool and we pop it, and you know how these work. But what really matters is that we're recycling these and we're not creating new ones each time. So yeah, so as you can see, we are in the client right now. So in the scene, you'll see that physics are not being used, and we have the inputs for player one, and that's about it. And in the server model, or the server side, for the scene, we are running physics, and then we are getting the inputs for player two. And since we're on client-side prediction, we are sending the position updates and missile updates for each player. So that is the basic networking. Next is the tools and support. So as you saw, we do have the ability to change delivery methods, such delivery methods and channels. So we have the unreliable sequence, whatever. I decided to make this because I could have done it in the message, but I just thought for some reason that like if you wanted to customize each individual message, like that's possible. And so I have it set so that you can set it for each individual message, the channel and the reliability. And then that all is processed once we think it's processed in process out of the queue there. Wait, no, it's not. Let me find this real quick. Oops, my alarm. Why am I blanking? Oh no, it is okay. So when we message to client, we changed the network manager send a message. So we're sending not only the serialization, but we're also sending the reliability and the channel. So when we go into our network manager, we have a switch case here, which basically just determines how to send the message. I did not do the recording feature, so we don't have that. And then now for the predictive algorithms, so obviously we're on client-side prediction now. So we have, I just lost it. Oh, we're on the server. So there's nothing done on the server. You saw that in the scene, we're still sending the positions every frame. So we're updating the position every frame. And in the client, we do have the prediction here. And so basically this just stores position, velocity, and time. And then you set that, and then you call like the get prediction function, which will return the estimated position that you should be at given these values that you provided. So that's used if we go to the game objects, let's look at ship. So if we go to the ship, we have our predictor, and then we just create it basis off of our initial values. And then every time we update, we get our predicted position, and then we set that to our position. And then if we get a message of that will change our position, we get to go to our player move, and then that will that'll change our position and angle, velocity, and then we update our prediction information. So yes, so obviously I can't show that to you because it's work, but yeah, that's the client-side prediction. And then we have Dead Reckoning. So on the client side, it looks kind of similar. So we have our Dead Reckoning predictive class, and it's looks very similar. It's pretty much the same actually. And so what's different is that actually I don't know if it's that much different. Oops, no, I don't want to go to game objects. I want to go to ship. Oh, and I forgot to show the missile, I think, last time, but it works very similarly. So we have our predictor. We set it to our initial values. And then, yeah, so we do basically the same thing here. Not much different when we go to our messages for our move. When we execute it, we basically do the same thing. And like I said, like we do pretty much the same thing for the missile as well. And what matters really is the server. So in the Dead Reckoning class, it is the same. However, what is different is not there here. So we still have our predictor, except we are also storing the threshold, which is how different the values need to be in order to send a message. And we also store the angle. We store basically all the information we need to that the client has to basically match the predictions. So here we set those values, and then in our update, we update ourselves and we update our position, and then we check if our positions are different enough where they need to be updated. And if they do need to be updated, then we create a message and we send that to the client. So in the missile, it's very similar. We do basically the same thing. This didn't have an update before, but now we are updating it. And so we just calculate those thresholds. If they're greater than our threshold limit, then we send a message over. And you see in our game scene play, it's cut down. All these comments are obviously not being used because we're not sending over the position, the updates for the missile or the position of the ships. We are just processing the inputs for player 2. So yeah, I think that's it for this. So thank you.